Hello, I'm Ryan McEachran, and welcome to episode 45 of The Dig. Joining us this week is my guest, Dustin Angelo, CEO and founder of Novamera. I'm excited to have Dustin on the show today, as we will discuss Novamera's innovative approach to mining steeply dipping narrow ore bodies from surface. And we'll finish things off with our classic 6 and 60. All this coming up right now. But first, a quick reminder to follow us on LinkedIn and on Twitter at Mining Suppliers. And also subscribe to our YouTube channel to make sure you get access to all our episodes of The Dig. When you talk to geologists and operators in the industry, you will hear about countless stories of discovering high-grade ore bodies at surface. It's extremely exciting, but when you apply conventional mining techniques, the economics don't pan out, and these deposits are left orphaned, unable to extract the value they contain. But what if you could find a way to change the economics by lowering the amount of water required, reducing the energy intensity, and drastically minimizing the environmental footprint, just by drilling them and taking the cuttings out to process? It would be a game changer. However, easier said than done. That said, one company is up for that challenge, Novamera. And in this episode, we have CEO and founder Dustin Angelo joining us to share their story and help us understand how their approach is going to transform the economics of these deposits. So let's dig in right now with Dustin. Hi, Dustin. Welcome to The Dig.
Hey, Ryan. Thanks for having me here.
Yeah, excellent. So tell us a little bit about what Novamera is and how it got started.
Sure. So just imagine that you've got a gold operation in Newfoundland. You're doing an open pit operation, fairly low grade, and just down the street on your property, you've got this seemingly higher grade, narrow vein deposit that can do wonders for your operation. It can add more grade and therefore more profitability. Well, that's what we had at Anaconda, and we had this narrow vein deposit called Romeo and Juliet, and it was about a kilometer from our mill, and we were looking at various different ways to mine this deposit when I was running Anaconda Mining with my now business partner Alan Cram, who was general manager, and we looked at different scenarios for open pit and underground, and no matter what we looked at on paper, we just couldn't make it work economically. And this deposit, seemingly based on exploration results, based on a few bulk samples, small ones, it had grade that was 5 to 10 times the grade of our open pit operation. So you can imagine how, we really wanted to mine this thing, but we couldn't figure it out. And then one day, Alan Cram, my partner, he was in the open pit looking at the blast hole drill holes from the drilling and blasting activities, and suddenly dawned on him, well, why don't we try drilling and to mine this Romeo and Juliet deposit? And that took us down a path of working with Memorial University in St. John's, Newfoundland. They've got a drilling technology lab. And about 4 years ago, we kicked off a program with them to start looking at researching how we could do this. And we ultimately figured out a way to do mining by drilling. Now, today we call it sustainable mining by drilling. And so Anaconda embarked on this challenge essentially to solve an internal problem. And, it's one that we were working on for a while. And then in 2019, we made it to the Disrupt Mining finals, and we're on stage in front of about 600 people in an audience during PDAC. And we didn't win, but I think we captured a lot of people's imaginations, because after we came off stage, everybody was talking to us, people that represented companies and projects all around the world, saying that they had similar issues that we had at Romeo and Juliet, being this narrow vein deposit, very steeply dipping, that couldn't be mined using conventional methods. So these companies weren't mining deposits. They had zones within their existing mine sites where they weren't mining. And suddenly the light bulb went off for us. It's like, holy cow, like this is a problem that's not only ours, it's an industry-wide issue. And that's when we decided to take this concept that we were working on internally and develop Novamera and spin it out of Anaconda Mining. So what we did was we went out and raised outside venture capital money. So we're funded by venture capital firms that have backed us to develop and commercialize this technology. And what we're creating is, like I said, what we call sustainable mining by drilling. And it's using, at this point in the first generation of our system, using conventional drilling equipment along with proprietary downhole sensors to essentially be able to surgically remove ore from the ground and leave the waste behind. So it's a lot more environmentally friendly, it's a lot more efficient, and it's a lot safer.
Wow. And I think you're touching on, I think, three of the main themes that we're seeing in the mine industry right now, which is how do you reduce your water intensity? How do you reduce energy intensity? And more importantly, how do you reduce your environmental footprint? And you seem to be checking all these boxes. It's so, ideally, this technology, it to me, as soon as you mention what you're doing, it's like, of course, this makes sense. It almost seems surprising no one's really kind of gone down this road, but easier said than done, I'm sure. And what's the ideal ore body are you talking about here? Like, obviously from surface, you're looking at doing it from surface, but how wide, how deep, what orientation of a vein are you looking at?
Yeah, so speaking in the context of sort of our first generation or early generations of this technology, we're looking at steeply dipping narrow vein deposits that are typically 60-degree dip to about 90 degrees vertical, typically around 1 meter to 2 meter wide. We think in the first generation of our system we'll go about 300 meters, and we're doing this from surface to start. The Romeo and Juliet deposit at Anaconda mining site, it outcropped at surface, so we were trying to solve a problem where we could start at surface. So that's why this technology has kind of gone in that direction. But there's a lot of opportunities out there to take existing drilling equipment and go underground. So that's certainly something top of mind for us, is to be able to take this underground and extend the life of underground operations as well.
Right. So maybe expand a little bit more on maybe kind of the process that you would be doing here. So you've got the vein, you're setting up the rig. What kind of rig are you like? Is this obviously as in coring? You're almost, I guess you're doing large diameter boring. Is that be a best way to look at it, or?
Yeah, but we actually do start with core drilling because we have a two-pass process where we establish a pilot hole that's ultimately going to guide that production drill, and we use that pilot hole and we guide that pilot hole by using our proprietary downhole sensor, our imaging tool. And so we establish that pilot hole and try to keep it centered in the vein, and we use the imaging tool that can identify the interfaces between the host rock and the mineralized zone to keep it centered. And so once we have a pilot hole established, then we come in with our large diameter drill, and we modified the cutting head to be able to follow the pilot hole. And then so that reams out the material to whatever depth. In this case, as I said, we're trying to go at about 300 meters in the first generation. And it reams out. If it's a 2 meter wide hole, we'll use a 2 meter diameter drill bit, and we'll bring the cuttings to surface using a low energy reverse circulation airlift assist method. So it's pretty, it doesn't use as much energy as you'd think. And then what we've got is these holes that you plan down the strike length of your vein. So you essentially do a series of primary holes and secondary holes. So you kind of skip every other hole for hole stability as you're drilling. And once you've got all your primary holes opened up, now you've got landform tailings capacity. So we use those open holes for reclamation. So for backfilling using the tailings from the processed ore. So you get that concurrent reclamation going as well. And also then you don't need as much constructed tailings capacity for your project as well, because you're using those holes in the ground. So then you fill all the primary holes, and then you come back in and you drill all your secondary holes and fill those as well. And you do that process all the way down the strike length of the vein, and then ultimately you have your deposit mined out.
Right. Well, that's a pretty wild. So where are you at with this this process right now? I think you're on site now as we speak, I guess.
Yeah, so we are in the middle of a full-scale field trial at the Anaconda mining site where the Romeo and Juliet deposit is located in Newfoundland. We're up on the Bay River Peninsula. We've been working for nearly 2 months doing our field trial. So we're testing the entire process. So this is a proof of concept trial, where we're just demonstrating that this concept can work. So we're drilling pilot holes. We're using our imaging tool to identify those vein interfaces. We're doing the production holes. So we're doing the large diameter drill excavation, in this case using a 1 meter diameter drill bit, and then we'll backfill the holes. So that whole process is what we're working on right now. We're not optimizing for speed or efficiency at this point. It's all about just demonstrating that this process can work. And we've drilled all of our pilot holes, and we're actually have just started drilling our first production hole. And we're seeing good things out of it so far.
Wow, that's exciting. So what would be the next steps here then? Where are you going from here? So you get the proof of concept, which is a huge milestone for you, I can imagine. So where would you like to take it in the next little near future? Walk us through that maybe.
Yeah, so the field trial itself is going to last till about mid-December. So we've got some more work to do here. So that's in the near future. That's our heads are down looking at finishing up the field trial. And then, we're already getting some great learnings out of the field trial in the first couple of months. So there's a lot of things that we can improve on, a lot of things we can fix. We're doing a lot of that in the field already to get a head start on those things. So, the idea for the the first half of 2022 is to work on all of those improvements and get the technology and the system ready for its first generation commercial rollout by the end of 2022. At the same time, we're making great strides on the business development side, right? So not only just sort of being able to develop the technology, but we're finding the markets for it. And we've already got interested parties. We've been working with a couple already, just doing some desktop studies to analyze the efficacy of SMD, sustainable mining by drilling, at their sites on their particular vein deposits. And then, we're talking to a whole host of other companies, and we probably have a pipeline of over 50 companies that we've had contact with, engagement, that are expressing interest in what we're doing. And those companies are worldwide. So we see that it's not just a great widget, so to speak, but it's there is a market for this technology and this system. So we're working in earnest on that as well. And then early part of 2022, after we finish with Romeo and Juliet, we're looking to deploy our system at another site. So we're working on trying to court those that may be interested in being the next site to use SMD. So that's that's going to take us till the end of 22.
Okay, well, that and mentioning that you're going to look at have it at commercial production by the end of 2022 is a pretty ambitious and exciting timeline as well. It sounds to me naturally. It's I've got a bit of a geologist background, so the precious metal piece makes sense, but I guess in the end, it's really a technology or a commodity agnostic technology. It just depends on what the dimensions and the orientation of these systems for you to utilize it.
That's correct. Yeah, I mean, it's obvious that one of our biggest markets, the main market to start off with, is the precious metals market. There's certain types of battery metals as well, and then like you said, it just depends on the geology and the structure and the orientation. That if it's highly concentrated but still hard to mine efficiently using conventional methods, it could fit SMD.
Right. Well, it's an exciting story, and you're like you say, you're at a real important milestone in your journey. So I really appreciate Dustin coming on the dig and sharing it with us, and look forward to having you back to share how it's progressing.
Well, yeah, thank you very much for having me, and I look forward to chatting with you in the future.
Awesome. Take care. Now it's time for 6 and 60. Let's take a look at some of the biggest stories in the mining industry today. Valley has launched a new green product made from iron ore in a special solution that will reduce gas emissions in steelmaking by up to 10%. Argonaut Securities was yet another firm to highlight constraints to supply the surge in demand by the EV market, citing skill shortages, permitting delays, and pandemic-related restrictions. After a decade ban on mining, Argentina's Mendoza province is negotiating with top potash producers to restart development of the Rio Colorado project. Analysts stated the U.S. lithium-ion battery supply chain is underdeveloped, with over 50% of the refined lithium imported from Germany and China. BHP formed an exploration alliance with Cobalt Metals, a startup backed by Bill Gates-led Breakthrough Energy Ventures. And finally, Wyloo Metals submitted a formal bid for Noront Resources valued at over $400 million, a 27% premium over BHP's offer. That is your 6 and 60. That's it for this week's episode. I'd like to thank our special guest, Dustin Angelo. And remember, you can follow us on Twitter at Mining Suppliers and LinkedIn. And subscribe to our YouTube channel to get instant access to all our episodes up to date. Thanks for joining us. Until next time, I'm Ryan McEachran. Take care and stay safe.